Alright, this is the second video that's going to finish up section 5.4. The last video, which I call the old school video, that's the one when I was sliding the whiteboards across. We did inequalities using the word or, and I'm going to review that. This is what we're going to do today. I'm going to change the word to end, and there's going to be a big difference, okay? Now, think of it. I'm going to give you something that's not even math related. If I told you that you had to clean your room or you had to eat dinner, that means you could do either one, okay? If I said, hey, you have to clean your room and you have to eat dinner, then you have to meet both criteria. So that's what we're going to do today. Now, a little review of or. Or, when you graph the solution set, another word for this, we say it's a disjunction. One's going to go to the left, the other one goes to the right. Okay, and even if I go over, let's say I go over number 1. I know this was on the last video, but just to refresh your memory, say this is 1, or say this is 1 and 2. Okay, here's 0, and here's 3. If I'm going to have open circles over 1 and 2 because it's not underlined. Okay, that's pointing to the left, so I shade to the left. This is pointing to the right, and I shade to the right. This is called a disjunction. Now, disjunction means they go the opposite way. Okay? Now, what we're going to do today, let's go to the end one. So let's go to the next page. Okay, for end, another word for this, opposite of disjunction, is conjunction. Now, think of it, if I said, a lot of times you use the word conjunction if you're talking about like directions or roads. So you say, hey, what's the conjunction of this address? You know, it would be where the 2 roads or 2 streets meet. So it's got to cover both streets. It's got to meet both criteria. Okay, number 7. I'm going to do number 7, number 8, and number 9. Number 7, there's a typo. Both the inequalities should be switched. So number 7 should be x is greater than 7, and, keyword and, x is less than 5. So let's graph this. Now, negative 7 and 5, I don't have to put every single point in between. I should know negative 7 is less than 5. So negative 7 is going to be all the way to the left, 5 is going to be all the way to the right. I could put a point in the middle, the origin, or 0 is not exactly in the middle, but probably a little bit closer to 5. So I want to put open circles on each. Now, I have to meet both criteria. I have x is greater than negative 7, so this would go all the way to the right. I'm going to put this next one in a different color. Let's put it in green. Good old Seneca green. Now this, I have x is less than 5, so I would put this right here. I would go everywhere to the left. Now remember, I said this is where, if you use the word end, you have to meet both criteria. Well, if you look at this graph, where do we meet both criteria? Right, I'll use a different color. Let's use blue to highlight this. This is where the green and the red meet. So when you graph it, I'm going to put this right in here. You're only graphing where these both meet. So what's in blue here, that's your answer. Basically everything in between negative 7 and 5, but you don't include negative 7 and 5. Because if you pick a number, let's say I pick 0. If I plug 0 into this, well, if I put 0 in here, well, 0, that's greater than negative 7, that's true. And if I put 0 in here, 0 is less than 5, that's true. So it has to be true for both inequalities. So conjunction, it's going to look like this. This is where they both meet. All right, let's do number 8. Now number 8, it's not written the same way. See how there's no word? If there's no word, then it's assumed to be this case with then. I'm going to rewrite this a different way. I'm going to put x first. Now, if I read this right to left, it's x is greater than or equal to negative 5. See how the open part faces the x here? And I'm going to put the word end. Then I can just do the second one left to right. I just look at this one. Then I have end, x is less than 3. Okay? It's probably easier putting it into that form because x is written first for both inequalities. So let's graph this. Negative 5 is going to be to the left. Then we're going to have 3. Right, 0 is going to be a little bit closer. Okay, again, I'm going to have open circles on each. Here I have greater than or equal to negative 5, so this goes to the right. I'll just put an arrow. Here I have less than 3, so this is going to go to the left. And again, where do they both meet? right here. So this is our solution set right here. Okay? Let's just do number 9. Okay, now number 9 is written just like number 8. What I want to do is I want to write out 2 inequalities. Now I'm going to write whatever's in the middle, that's going to be what's common for both inequalities. So another way of doing this is I'm going to have 2x minus 1. And see how the open part of the inequality symbol faces the 2x minus 1? So when I write it first, I have to switch it. The open part still faces the 2x minus 1. Then I'm going to put this negative 3 down. And then I'm just going to write the word end. And then the other one is just this whole inequality. 2x minus 1 is less than or equal to 5. A lot of math is just bookkeeping, staying neat, staying organized. That's very important. I guarantee if you don't do that and you try to solve both inequalities at the same time, most cases you're going to make a mistake. So just set them up, have the words end, and solve for one inequality, and then solve for the next one. So let's solve each of these one at a time. Now I'm going to put the line straight down. You have a 2-step inequality. When solving these, they're very easy. Just take your time. So this, we're going to add 1 to each side. This cancels. I add 1 here. I bring down the 2x. Negative 3 plus 1, that gives me negative 2. It's greater than or equal to. Then I divide both sides by 2, and I get x by itself. Now I don't have to switch the inequality symbol because I'm dividing by a positive 2, not negative 2. So it's greater than or equal to. Negative 2 divided by 2 is negative 1. All right, so I'm going to circle this. Then I'm going to worry about the second one. So solve the first one. Don't worry about the second one until the first one's solved for. So take your time. Okay, just draw the line straight down the middle. I'm going to do the same exact steps that I did for the first inequality. I add 1. That cancels. I add 1 here. So I have 2x is less than or equal to. And then this 5 plus 1 is 6. Then I divide both sides by 2. I don't have to switch the inequality symbol because I'm dividing by positive 2 again. 6 divided by 2 gives me 3. And I'm going to put end. So let's put negative 1. Let's put 0 next, and 3 is a little bit further down. Now, since these are both underlined inequality symbols, it is a closed circle. So negative 1 and 3 are part of the solution. Now, x is greater than or equal to negative 1. This goes to the right. X is less than or equal to 3. This goes to the left. And this is where they both meet. Okay? So that's pretty much it. You can see the difference here. The end, this is where they both meet. They both converge. But solve each one separately, just like you did the OR, and then graph the solution set.